Hi, I'm Professor Divya Nayar and I'm Assistant Professor at Department of Material Science and Engineering. I joined IIT Delhi in 2020 as Assistant Professor here. A little bit about my academic journey so far. So before joining here, I was Assistant Professor at IIT Kharagpur at Center for Computational and Data Sciences. And before that, actually, I was a postdoctoral research associate at Technical University of Darmstadt. So my journey has been quite interesting because I'm a computational chemist. So I did my bachelor's and master's in chemistry from St. Stephen's College at Delhi University, followed by a PhD in computational physical chemistry at Department of Chemistry, IIT Delhi, with Professor Shita Chakravarti. So when I had joined this subject, to pursue my interest in chemistry, actually I was really interested to understand why processes or why natural processes as we see in biology happen the way they happen. And what fascinated me was how we can use mathematics as one of the tools to understand these processes. So that led me to pursue my interest in chemistry, because I could see that there was chemistries everywhere, and it is in interaction of molecules which makes matter and makes interesting materials. So after that, venturing into the computational sciences, it really triggered my interest to further pursue these interests, to understand how we can design materials in using computational methods, using mathematics as one of the tools. So this has been my journey so far, and I would like to tell you a little bit more about my work and interests.
Well, one of the first questions that we wanted to ask you were, what career opportunities and pathways can the students expect to pursue after they've completed their degree in material science and engineering here from IIT Delhi?
Yeah, so there are many avenues that students can explore. One of them is to pursue in academics, like we have ended up here. So to pursue research, and that is doing a PhD, bachelor's followed by master's, and MSc by engineering if you are a BTech, and then for doing PhD at one of the reputed institutes. The other avenue would be to go into industry, and there are a lot of R&D positions available in industry. So related to, so in our department, since we have so many verticals available which you can specialize in, so there are industries working with polymers, there are industries which are focused into working with high performance materials, with metallurgical applications. So, and one of the areas where I am expert in, and I can tell, is that there are a lot of R&D positions where computational skills are required. And computational material science is one of the major upcoming areas, as you can see, with AI and machine learning. To design and discover new materials using computational tools is something what industry is looking forward to. So students who graduate from our department will get a feel of all these areas which I have just not told. And specifically, I can tell more about my area. So there are companies like Google, Amazon, Facebook actually is also doing R&D in materials. Actually, there are options there, and then there are pharmaceuticals also where you can use computational bio-inspired materials are being ventured into. So these are the areas where students can go after there.
So ma'am, please tell us a little about your field of research.
So our group is called Computational Soft Matter Group. We are the people who work in doing simulations of soft materials. So computer simulation is an effective tool to zoom into any kind of material at a microscopic level. So we are the people who work at molecular level, and we can use certain computational tools to tell engineers and scientists why a material behaves in a way, or what should we do to design this material in a better way, or what is the phenomena behind certain kind of processes that material is involved in. So our work is focused towards designing bio-inspired nanomaterials. We like the idea how nature has actually designed self-assembled materials inside a living cell. So if you are aware of biomolecules, like we have proteins and DNA, which is the basic component of a living cell and of functioning of our body, it actually acquires a very nice, beautiful, three-dimensional structure to function the way it functions. And this happens inside a very crowded environment of a living cell. and nature has its own forces by which this happens. So we are trying to understand the physics behind this whole phenomena, that if we understand how nature propels these self-assembly, then we can use this as a tool to design self-assembled nanomaterials. So when I say nanomaterials, these are the materials that have very interesting properties at nanoscale. For example, gold. Gold is a metal which you've seen in bulk in ornaments, but when you take it to the nanoscale, it starts exhibiting very interesting properties. And one of those properties is that it can be used for target-specific drug delivery applications. So we in our group are designing biofunctionalized gold nanoparticles, which are like DNA functionalized gold nanoparticles, which have the capacity, which find applications in biosensing, biodiagnostics, drug delivery. So in our group, we are trying to self-assemble these nanoparticles using the idea of a living cell crowded environment, and because that makes it tunable. We can tune the assembly the way we want based on the properties we want this nanomaterial to have. So our group focuses on areas of molecular simulations where we use concepts of thermodynamics, mathematics, biology, chemistry, material science. It's a quite interdisciplinary field. And we make use of the advanced computational tools, not only simulations like programming, and also we are now venturing into machine learning, where we are using machine learning methods to predict the design of these nanomaterials and in drug discovery.
So, as a first year or a second year student, if someone is interested to explore these topics under professors like yourself, so where do they start if they want to take up a project per se?
Okay, that's very interesting and nice questions. Good that you asked. So there are a lot of opportunities outside the classroom to interact with professors. So one of them is that you can do a summer internship, summer projects or winter projects when you have vacation. So you can write to any professor of the institute, I would say, any department whom you are interested to pursue, and just write to them and interact with them, and if there is a position available in the lab, they will offer you a project. The second way is that you can also have design credit. By doing these kind of small projects, you can earn a design credit, NGU credit, I think, 1 credit that you get for that. The third way is Sura project, where the institute also gives a little bit of fund to pursue a research project with an objective. So one of the good things is that when you do such a project or some small internship in a group like a research group, you would actually get not to only interact with the professor, but you also get to interact with the research scholars in that group. And that interaction, I feel, I have seen with my experience so far, that has been very fruitful for the bachelor students. Because the learning that they have, so for example in my group, I have small projects which involve writing a long code, for example, a long program that we want to write to analyze some properties of the system we are trying to study. So we require expertise. Some bachelor students already are very good at programming. So we can offer you to write a program for that particular problem, and within stipulated frame of time, you actually are able to connect the ideas of computer science and maybe biology, physics and engineering together to solve a research problem. And I think this small exposure, which is not available usually in the classroom because we are restricted with a timeline to complete this course. So this is something, an additional thing which students definitely should explore, because they not only get to learn new things, but they also get to connect the ideas, which is very important to have in mind while you pursue certain interests or decide what to do next in your future.